So first, to recap quadratic inequalities, we solved them first like regular quadratic equations. So first, find the x-intercept or the zeros. Find the roots. By making it equal, I'm going to distribute that 3, move everything over to one side. And it's fastest if you can factor, but if you can't factor, you can use the quadratic formula. It's going to be 3x and x, 3 and 1, minus and plus. After you factor, quickly multiply it out to check to see if it works. And it does. Yes. This is on page 343. 7 cubed. And so our solutions are x equals -1/3 and x equals 3. So it starts off, to solve a quadratic inequality, you go back to chapter 3 and solve the quadratic equation. Then, once you've solved the quadratic equation, you make a number line with those two solutions on there. So we would have -1/3 and 3 on our number line. And in this case, since the original equation had less than or equal, right? Because once I moved everything over, the original equation would have had a less than or equal to 0 here. Then when you put these circles on here, you fill them in because of the equal sign, meaning those will be part of the solution. Because at -1/3 and 3, it's equal to 0. But we want to find out when it's less than or equal to 0. So at this point, we have some options, because we need to find out which sections are true and which sections are false. You could use the graph. If you drew this graph, and you already knew that there was an x-intercept at -1/3 and an x-intercept at 3, will that parabola open up or will it open down? It'll open up. So if I drew the parabola through those points, maybe I'll make it blue. What we're trying to find is which section is less than or equal to 0. So based on the parabola, you can say this section is true and these sections are false. Because on the parabola, this is the only part where the y values are less than 0, where they're below the x-axis. The other way of finding the true and the false sections is by testing certain values. If I want to test a value in between -1/3 and 3, I could plug in 0. If I plug in 0 into the equation, is -3 less than or equal to 0? Yes, this section is true. If you test a point larger than 3, say 5, if you plug 5 into the equation, well, it's a little bit more math. You'd have 5 squared is 25 times 3 is 75 minus 40 minus 3. Is it going to be less than or equal to 0, or is it still positive? It's still positive, so that section would be false. I actually really like the factored part for checking to see if something is going to be positive or negative. Can you see that if you plug in 5 into the factored part, and I'm going to put the symbol back in here, wow, less than or equal to 0. I'm going to put the symbols back in there, and I'm going to test 5. Can you see in this first set of brackets, if you put in a +5, that this number will be positive? I don't even care what number it is. It's going to be a positive number. And if I plug 5 into this set of brackets, 5 minus 3 is 2, it's also a positive number. What happens when you multiply a positive number times a positive number? You get a positive number. Will it be less than or equal to 0? No. So we can tell that this section to the right of 3 is going to be false. And you can pick any number, and if one is false, they'll all be false. Because if we look at the graph, if you pick any number in this section here, it's all above the y-axis. So we can either pick test points to check where things are true and false, or we can look at the graph to check where things are true and false. You find as you go higher in mathematics, especially in calculus, often the graph isn't easy to have a picture in your head, then the test points make more sense. But at this point with parabolas, it's really easy to see, is the parabola opening up or opening down? That can really help you get the true and false right away. So then we write our solution. And our solution in this case is between -1/3 and 3. The dots are filled in. So we have the equal sign included with them. You can write it in set notation, or you can use interval notation. So you get to choose how you want to write the solution. We use the square brackets because 3 and -1/3 are included. Today's homework's brought to you by 7-Eleven and the Slurpee. You missed it.